Alright guys, so the next few videos are going to introduce you to non-parent functions. Now when we say that, really all we mean is that we're taking our parent functions and we're doing things to it. And when we say do things, we mean arithmetic operations. Now arithmetic operations are plus, minus, multiply, or divide. And the multiply can also be done with the dot, right? The divide can also be with the fraction sign. But plus, minus, multiply, divide. So as long as you're doing those operations to x, then the parent function will stay essentially the same. It'll be similar, right? It might move, it might change its angle slightly, it might stretch a little, it might even flip upside down. But the point is that for the most part, the final result will have a very similar appearance to what you originally have. And my goal in the next 4 videos is to kind of show you this and show you how we're going to get those parent functions. Okay, so let's go ahead and look at the first one here. By looking just at the equation, can you guess what this curve or what this line is going to look like? Hopefully you look at this and you say, well, there's not an x squared, so it's not quadratic. X is not an exponent, so it's not exponential. And there's no absolute value bars, so it's not absolute value. So my best guess would be linear. Note that it's being multiplied by -3, and then it's subtracting 2. Both of those, multiplication and subtraction, are arithmetic operations. Therefore, we can say, yes, this should be a linear graph. So what we're going to do is we're going to fill out this chart as we go. So I got the name of the parent function, which is linear. And if we get outside of the box, that's okay. It's just a box. I mean, it's just lines, for heaven's sakes. All right, so we're going to go ahead and we're going to see if we can maybe graph this. Okay, now we could answer more of the questions, but let's just go ahead and go forth with what we have right now. So before, when we created a table, we used the central values, -2, -1, 0, 1, 2. A lot of the time, those numbers will work, and they're the smallest numbers, so they're easy to work with. So let's go ahead and try that. Let's put in -2 for x. So I'm going to go -3 times -2 minus 2. So I'm just taking -2 and I'm putting it in for x, substitution, what you learned in our first unit. -3 times -2, negative times negative is +6, minus 2 is 4. Okay, so I go to that point, I go -2, 4, and I put a point there. All right, let's try -1. So I go -3 times -1 minus 2. And I know you're going to ask, do I really need to show my... Yes, you need to show your work there. Monkey math, it needs to be simple enough. If all I see is numbers in the table, then I'm not going to believe you, and you're going to have to go redo it. -3 times -1 is +3 minus 2, and you get 1. So we go to -1, 1. Now, yes, you may know shortcuts, and you can use those shortcuts to check your work, but right now I need to see that you understand that I can put values in for x, and that I can get values out for y. 3 times -3 times 0 is 0, minus 2 is -2. And if we continue forward with that, you can do the other values as well. So I'm just going to do that. So note that I did 1 and 2 over here. I put them in, put them on my table. I put all my points down, 0, -2, 1, -5, and 2, -8. And you should notice, yes, that we have a reasonably nice straight line, just like we guessed. So the shape, of course, would be linear. Okay, so let's go ahead and draw on the line that we know we have now. So we go ahead and draw on the line. Please do it fairly straight. Don't forget the arrows on the end. Remember, the purpose of the arrows is to show that we understand that the line keeps going. Okay, that's important because, yes, I put in -2, -1, 0, 1, 2, but I could have just as easily put in 3 or 3,000 or -3 million, right? And so all of those values need to be considered as part of our line as possible solutions to this equation. So we've got a linear. We can do domain. We see that it does go, this is going down, but it's also going to the right, so it keeps on going to the right. This one keeps going to the left. There's no possible way for me to write all of those values, and so I can either use an inequality, or I can just say, well, if it's going to the right forever and it's going to the left forever, that means that x is all real numbers. It's a similar thing for range. Yes, it's going to the left there, but it's also going up, so it does go up and up forever, and it does go down and down forever. And so if it goes up forever and down forever, then the range is y is all real numbers. Okay, our x-intercept we'll look at, and we'll say, okay, well, there's my x-intercept right there. Now, it looks like it takes... If I go down 3, I go over 1, right? And some of you are familiar with that as the slope. That means that this probably isn't right at 1/2. It's probably a little bit to the left. So I can get my x-intercept. It's probably going down 1 over 1/3, down 1 over 1/3, down 1 over 1/3. Okay, so I'm actually going to say that my x-intercept is negative 2/3 because it's 1/3 over from there, comma, 0. Okay, because the x-intercept is a point and I should label it as such. The y-intercept, you can see the y-intercept is right here. So the x value is 0, the y value is negative 2. So again, the y-intercept is the point where the line crosses the axis, the y-axis, and so I should write it as a point. Okay, so I've got the name of the parent function already. We knew it was linear. The equation of the parent function is just simply y equals x. And the special feature here is that it has a constant slope. Now, that's fine for now. If you know enough about slope that you can tell me what the slope is, that would be awesome. If you know enough to say that the slope is negative 3, then that would be great. That's not required for now, though. That's a little bit of extension. The negative 3 just represents that you're going down 3 over 1. Okay, so that's a linear graph. I talked you through each of the pieces. Note that we didn't have to fill out the whole table. You need 5 points on your graph. If you got 5 points on your graph, then you're done. As long as you can see all of the important features, the domain, range, x-intercept, y-intercept, as long as you can see all those important things, then as long as there's 5 points, you can see those, you're good to go. All right, so that's a linear non-parent function.